Hello and welcome to Animated Education. Today we are going to talk about integrals. So, an integral is basically an area under the curve of a function. It can also be used to find volumes, areas of various geometrical objects, and so on. But we are focusing on area under the curve. So, if we have x and y axis, and we have some function, let's say it looks like this, and we want to find an area of this function, of the area under the curve of this function. It is, and let's say this is a and this is b. So what we need to do is to integrate from a to b our function f of x with respect to x. So this would give us area. So how does this work? Okay, so let's say we have the same function. This is x-axis, this is y-axis, and it's almost the same function. And we want to how could we calculate it? So this is delta y and this is delta x. So we could try to calculate an area by multiplying these two numbers, and we would get an area of all this thing. So it wouldn't be very accurate because we only need this part, but we also would get this part. So what can we do? Well, we can try to approximate it a bit better. So we can take two figures like that. So this would be delta x1, this would be delta x2, this whole thing would be delta y1, and here would be delta y2. So our area would be delta x1 times delta y1 plus delta x2 times delta y2, and we would get this green area. So now we are left with this unnecessary part. Okay, so it's a bit smaller the next time. We don't get all this unnecessary as we did in the previous example. So what if we make delta x's even smaller? Well, here's what we would get. Now all of this is delta x, and each of them is delta x. So, and this is the height, the value in y-axis could be calculated as f of delta x1, this is delta x1, f of delta x2, and so on. Now we can write it that our area is a limit, then n approaches 0, excuse me, not 0, infinity, then n approaches infinity, and we put a sign of sum here. We have n number of these squares and we start from 1. So here's how you write it. Don't worry if it's new to you, because it doesn't really matter. So n approaches infinity, and so delta x is basically 0. So now our area, approximated area, is, well, it approaches approximated area approaches actual area. So this is basically a definition of an integral. So here's what we get. We get that our area is an integral from a to b of a function f of x with respect to x. So our integral sign basically replaces the sum sign. So this is a definite integral. Let me write it. Definite integral. So the definite integral is an area under the curve. So what is indefinite integral? We also have that. So okay, so what is indefinite integral if definite integral is an area? So indefinite integral is basically a formula, okay? It's finding an integral is a reverse of finding a derivative. So if we have a function of a derivative, okay, let's say this is 2x, and we want to find out what the function was before finding a derivative, we would need to calculate an integral. So a general way of writing this is like that. This is a function of derivative, and this is our previous function. Let's say our function of a derivative is 2x, so our previous function of a function was like this, and this gives us x squared over 2x squared over 2, and this is, excuse me, I forgot something important, plus a constant, and this is equal to x squared plus c. Now c is a constant, any real number, okay? It's absolutely any real number. Why we need it? Well, here's why we need it. So let's say we are calculating a derivative of x squared. This will be 2x. Now let's say we are calculating a derivative of x squared plus 4, and the derivative will be 2x. Now let's say we're calculating a derivative of x squared plus or minus 7. This will give us 2x. So they put a c here, where c means any real number, and they say that it's still 2x. So a reverse function, when we are integrating 2x, we must add this c, because we don't know what c was. We can't determine it, but so there's why we put this c here. So yeah, that's indefinite integral. Here's one more thing I want to talk about in this lesson. The concept that integral is an antiderivative of a function is very well applied in physics. So in the last lesson we learned that as the derivative of a function of displacement is velocity, and a derivative of a function of velocity is acceleration. So now, knowing that integral is an antiderivative, we can also say that we can find a displacement by integrating a function of velocity with respect to time, and we can also find a velocity by integrating a function of acceleration with respect to time. So yeah, that's about it. In the next lesson I'll show you how to find an antiderivatives and how to calculate an area under the curve of a function. That should conclude my short course of mathematics before learning physics. I must admit that it was longer than I thought it would be. Well, it just proves how much mathematics we already know. See you next time.